to Lecture 20, Unit 4. This is the normal distribution, and my name is Jorge. So in this lecture, we're going to be talking about the normal distribution. We're going to identify distributions as symmetric or skewed. We're going to identify the properties of a normal distribution, and we're going to find the area under the standard normal distribution given various z values. So the normal distribution is known as the bell curve. It's symmetric about the mean and the mean, median, mode are all equal to each other. Now, when the data values are evenly distributed about the mean, the distribution is said to be symmetric. So here we have three possibilities. So negatively skewed, normal or no skew, or positively skewed. So if it's negatively skewed, then the median and the mode are greater than the mean, and the tail is towards a negative direction. If it's positively skewed, the tail is towards the positive direction, and the mode and the median are less than the mean. And if it's normal, it's just symmetric. So here, let me review again. When the majority of the data fall to the right or to the left of the mean, the distribution is skewed. If the majority of the data fall to the right of the mean, is negatively skewed, and if it rolls to the left, it's positively skewed. The tail indicates the direction of the skewness. Now, the mathematical equation for the normal distribution is the following equation, but we're not going to deal with this one because it's already been done for us. But in this formula, E is the constant 2.718, pi is just approximately 3.14, mu is the mean, and then sigma is the population standard deviation. So a normal distribution is a continuous symmetric bell-shaped distribution of variables. So here we have two normal distributions with the same mean of 52, but different standard deviations. So here you can see that the one with the standard deviation of 6 is tighter. It's more clustered around the mean. With the one with the 12 is a little flatter and is more spread out. And that makes sense because the standard deviations, the one with the 12 is twice as large, and so therefore is more spread out. So here we have another one. This one has the same standard deviation of 12 and different means. This one has a mean of 52 and a mean of 76. So you can see they're centered around the different values, which is the mean, but the general shape of the bell curve is actually similar. So this one, the red one, has a mean of 30, standard deviation of 8. Again, the standard deviation is relatively small in relation to the mean. That means it's going to be more tighter. The blue one has a mean of 50, standard deviation of 20, so it's going to be more flatter, more spread out. So it kind of brings standard deviation, makes it tangible, if you will, so you can actually see it. So let's summarize some properties. Normal distribution is bell-shaped. The mean, median, mode are equal. They're located at the center of the distribution. Is unimodal. The curve is symmetric about the mean, which is it basically means that the shape is the same on both sides of a hypothetical vertical line that passes through the center or the mean. Curve is continuous. That means there are no gaps or holes. And for each value of x, there's a corresponding value of y. Now, the curve never touches the x-axis, so theoretically, no matter how far we go in either direction, the x-axis is what we call an asymptote. So the total area on the normal distribution curve is equal to 1 or 100%. Now, we can prove that using calculus, which we'll not do in this course. And so some very important information about the standard normal curve or the normal distribution. 68% of the data points fall within one standard deviation, 95% within 2, and 99.7% within 3 standard deviations. That means that if I had a data set and it was approximately normally distributed, then theoretically speaking, 99%, almost 100% of data points will be plus or minus 3 standard deviations from the mean. And this is what that looks like. Symmetric, so that means from -1 to 0 will be 34%, from 0 to 1 will be 34%, and so on. So the next thing is the standard normal distribution. The standard normal distribution is a distribution with a mean of 0 and a standard deviation of 1. So a normally distributed variable can be transformed into a standard normal distributed variable by using the formula for the z-score, and we did this for project 2. So here we have some values, and I'm going to show you 2 ways of finding them. Some of them are easier to find using the distribution tables, which I made available, and some of them are actually easier to find using the website that I have for you. So for this particular one, I'm not going to use the website. I'm going to use the distribution table. So we're going to find the area value for when z equals 1.39. So Here's a distribution table. So here, what I do is I go to 1.3 and I look for the 0.09. So the intersection of this of the row and the column gives me 0.4177. So the value that corresponds to a z-score of 1.39 is 0.4177. Now, for this one, it says find the area to the left of z equals 2.06. So for this one, I'm actually going to use the website. And if you click on it, it takes you to this website here. Let me close some of these. And what you want is you want the non-Java one, because otherwise it's going to give you some issues. And so what we're looking for then is to the left. And the left means that it's below 2.06. So when I go back to the website, here I'm going to click below, and I'm going to go ahead and put 2.06. And if I hit calculate, it gives me the answer, and the answer is 0.9803. So remember, to the left means below. Now the next one is find the area to the right of when z is equal to negative 1.19. So again, we're going to go ahead and use the website. So to the right is above, so it's going to be negative 0.119, and that answer is 0.883. And the shaded area is the area underneath the curve that we're looking at. So the next one is we're going to find the area between z is equal to 1.68 and z is equal to negative 1.37. And again, we're going to go ahead and use the website. So it's going to be between. So it'll be negative 1.37 and 1.68. We hit recalculate and it gives us the answers, which is 0.8682. Okay, so now, so a couple more points. A normal distribution curve can be used as a probability distribution for normally distributed variables. The normal distribution is continuous. The area under the standard normal distribution curve can be thought of as being probability. So when we talk about probability, the notation is slightly different. So for example, if the problem is to find the probability for any z value between 0 and 2.32, then that would be written as probability that 0 is less than z less than 3.32. In a continuous distribution, the probability of any exact z value is 0, since the area will be represented by a vertical line above the value, but in theoretically, vertical lines have no area. So probability that a is less than or equal to z less than or equal to b is the same thing as probability of a is less than z less than b. So for this one here, we're looking for the probability that z is between 0 and 2.32. And then z is less than 1.65, or the probability of z is greater than 1.91. So let's go to this one, that z is between 0 and 3.32. So again, when you click on it, just make sure you click on the non-Java one so you can get it. So what we're looking for then is the probability that's between 0 and 2.32. So if we do between and we put 0 and 2.32, we get our answer, and then our answer becomes 0.4898. So about a 49% chance that the z-score is between 0 and 2.32. So less than 1.65. So it's going to be below 1.65. So I just click on below 1.65. And it's about 95% chance that the z-score is below 1.65. And the last one is that the probability that z is greater than 1.91. So it's going to be above, and then we just put 1.91. And then we get about a 2.8% chance. So it's a pretty small probability. So the next thing is find a z value such that the area under the standard normal distribution curve between 0 and z is 2.2123. So for this one, it's actually easier to go to the distribution tables, and that's what we're going to do. We're going to go to the distribution tables. So here, if you notice that it's going to be between 0 and z. So this is my 0, this is my z, and that's what these values give me. Now I'm looking for 0.2123, and here you can see my 2.2123. So to find that z value, all I got to do is go here, so it's 0.5 and 0.06, so it's 0.56. Now, if I were using this, I couldn't put in the 0.2123. I would actually have to put in 7123. And the reason being that is because I am looking for the area that corresponds to the value that's below 0.56, if you will. And the reason being is because now if I were to just put 0.2123, you would see that it will give me a different value, right? So that's not what I want. What I want is actually really want from 0 to 0.2123. But if I want to do below, and if I do it this way, it gives me all of this that's below 0, which I don't really want, but I know that that's 0.5. So if I add 0.5 to the 0.2123, it gives me my value. So you can do it either way. You can kind of play around with it, but some situations it's actually easier to use the distribution table. So the websites here are both the same, and they're actually come in handy and make life a little easier. And that's the end of Lecture 20, Unit 4. Thank you.